Once we've plotted the regression line, we're still not done. It's helpful to look at some diagnostics to check to see if our regression model is appropriate. The chief among these diagnostics is the residual plot. The residual plot is a scatter diagram of the residuals. It should look like an unassociated blob if we have linear relations, but it will show patterns for nonlinear relations. The residual plot is used to check whether linear regression is appropriate. Look for curves, trends, changes in spread, outliers, or any other patterns in the residuals. The average of the residuals is always zero, no matter what the scatter looks like, just as the average of the deviations from the mean is always zero, no matter what the data look like. Let's see all of this in an example in our demonstration. We'll look at data about dugongs. Dugongs are this adorable marine mammal pictured here. They're a relative of the manatee. Here's some data about dugongs. And if you look, we've got length of the mammal, and we've also got its age. And we're hoping to use the measurement of length in order to estimate the age of the animal. It's always a good idea to produce a scatter plot to look at your data itself. And here we've produced a scatter plot of age versus length, and we see a very strong positive association here. There might be some quibble about whether the data has a curve to it or not, but definitely we see a strong positive association. And if you calculate the correlation coefficient for length and age, you find that it's almost 0.83. That's a pretty high value, and that's consistent with our strong linear trend. The following commands define and plot the residuals. Here's the command that defines the residuals, and here's the command that plots the residuals. And both of them take a table T and two labels for columns of that table telling us what the X and Y data look like. And if we run this data, or these commands on our data, we find that we get this picture. And this picture here is showing us the regression line. Sometimes it can be hard to see the residuals just from the regression line on the same scatter plot. And so we like to plot the residual plot. Here we've plotted the residuals themselves against the length, against the predictor variable. And here you see some interesting patterns in the residuals themselves. And it can be easier to see a pattern in the residuals when looking at this second residual plot. The residuals for low length are positive, and so are the residuals for high length, whereas the residuals for medium length are negative. That's an unusual pattern in the residual, and it suggests that maybe there's a quadratic function that could fit the residuals, and even a quadratic function might be a better fit to our data. Section 15.4 has material on fitting a quadratic function to this particular data. Here it doesn't make that much of a difference, but sometimes it's a good idea. One thing that's more alarming here is the big range of residual values for large length. Look at this huge range of residual values compared with the residual values for smaller length animals. It's a little hard to tell whether this is just the result of a couple outliers here, or whether we really have heteroskedasticity in our data. Heteroskedasticity is a fun word. It refers to uneven variation in the residuals in our data. When we have uneven variation in our data, we need to be particularly careful in drawing conclusions from the data, since the statistical theory of the regression line is developed under the assumption that the variance in y is constant across all x values, and so we would expect to see a kind of constant size of the residuals, a constant spread of the residuals here across all of the x values.